Hello. We're still solving linear equations, so nothing too complicated, but I'm just going to show you a technique if they involve fractions or decimals that is helpful, and it's going to be helpful going forward with more difficult algebra. So let's learn it now. Okay, so the best way to learn this stuff is just to look at examples. So solve 4/3 x minus 7/4 x equals negative 5/4. You can solve this directly just the same way we've been doing, by combining like terms. But the gist of this is nobody really likes dealing with fractions. So there's a simple and effective and powerful way to just get rid of all the fractions. It's sometimes called clearing fractions. And the way you do that is you say, okay, if I took 4/3 and multiply that by 3, I would cancel out the denominator. But I can't just do that. So if I took 7/4 and multiplied that by 4, I would get rid of that denominator. But what we want is a number that we can multiply everything on both sides of the equation by in order to get rid of all the denominators. And that particular special number is the least common denominator. So you want the least common multiple of all three denominators. All right, so it's the least common multiple of 3, 4, and 4. I know that's a little redundant, but it has to be all of the denominators. So if they were all different, then you'd have to find the least common multiple of three numbers. But here you just need the LCM of 3 and 4, which, you know, they're relatively prime, so you just multiply them together. The least common multiple is 12. So before we even do it, though, convince yourself that that's going to work. If we do 4/3 times 12, it'll cancel out the 3. If we do 7/4 times 12, it'll cancel out the 4. If we do 5/4 times 12, it'll cancel out that 4. So as long as we do it on both sides, which we can, we'll be left with an equation that doesn't have any fractions. Like that. So use the distributive property, right, to distribute it to every term. On the right-hand side of the equation, that just goes away. So you can cancel out a factor of 4 from the 12, and it's just 3 times negative 5. On the left-hand side, we still got a little bit of work to do. So that first term is going to be 16x, right? That next term is going to be minus 21x. Like so. So we'll do more examples of that, but if that looks confusing and doesn't seem right, just go back and try it again. Just as long as you get that I can do that, right? I can multiply two sides of an equation by anything I want. Okay, so we've done it. We've cleared the fractions, combined like terms on the left-hand side. So 16 minus 21 is negative 5. Divide both sides by negative 5 or multiply by negative 1/5. And 15 times negative 1/5 is 3. So the more we do this, the more I'm kind of going to not show every single little step, because I think you can probably do 15 divided by 5 in your head. I hope. Okay, so for that last one, you know, you're more than welcome to go back and plug it in and check to see that that is the correct solution. So let's just do another one. 2x plus 3 over 4 plus 3 equals 3x plus 19 over 8. So this looks more complicated, but it's really not, and it's a linear equation involving fractions. So the 3 doesn't have a denominator, or you can say that the denominator is just 1. So the thing we need to multiply by is the least common multiple of 4 and 8, which is 8. Right? If the bigger number is already a multiple of the smaller number, then that bigger number is the least common multiple, because obviously 8 is a multiple of itself. Now in this step, it almost looks like we've made it more complicated, right? We've added stuff where we didn't need there to be stuff. But you know that in the next step, it's about to get simpler. That's the point. Okay, so on the right-hand side of the equation, that 8 just cancels out the 8 in the denominator, and we're just left with 3x plus 19. On the left side, you know, I did a little bit of, I didn't show every single step, but the 4, this 4 is going to cancel out, and then this 8 is just going to become a 2, because you divide a 4 out of it. So parentheses become very important here. It's 2 times the entire factor of 2x plus 3. The 8 distributes to the 3, and it's just 8 times 3. And then right-hand side of the denominator just straight up went away. And now, again, we're back to where we've been. Distribute, get rid of the parentheses, combine like terms, algebra. So we have 4x plus 6 plus 24 equals 3x plus 19. 6 plus 24 is 30. And then you want to get all the x's on one side. So the best way to do that here is to subtract the 3x from both sides. And then notice I did 2 moves at once. That's not cheating. I would encourage it, right? Quicker is better in life. Not always. But there's absolutely nothing wrong with you doing that. So I subtracted this 3x from both sides, and I also subtracted this 30 from both sides, right? Because I want all the x stuff on one side, and I want all the constant stuff on the other side. And then we're done, because 4x minus 3x is just x, right? Or 1x. 19 minus 30 is negative 11. So again, it wouldn't be that easy to plug this into the original equation, but I would still encourage you to do it. If the equation you're given involves decimals instead of fractions, you know that a decimal is just another way to represent a fraction. In fact, a decimal is always just a fraction just out of some power of 10. So you're going to do a very similar move. So, like, I'm showing you this because this is a way to do these types of problems without a calculator. Okay, x minus 0.25x equals 120. On the left-hand side, you see right away that we can combine those like terms. X and 0.25x are like terms. Now, you can think of it as x being 1x. So when you combine those like terms and subtract the coefficients, you have 1 minus 0.25, which is 0.75. If that's weird to you, I don't think you should have to do like sort of long subtraction on 1 minus 0.25. Just think about it. It's 1 minus a fourth. So it's 3/4 or 0.75, or it's minus 25%, and what you're left over with is 75%, right? However you think about it. So like I wouldn't really need, there's a wasp in my face, I wouldn't need you to show work for that step. Okay, now if you had a calculator, you could certainly do 120 divided by 0.75. Or you could do it the old-fashioned way with long division. But I think we can do it without a calculator. And what we're going to do is, so we want the same as last time, we want these all to be whole numbers. We don't want them to be decimals. So to get 0.75 to be a whole number, we have to move the decimal place over 2. Moving the decimal place over 2 times is really multiplying by 100. Okay, so if we multiply the left-hand side by 100, it just becomes 75x. We can do that as long as we multiply the other side by 100. So if you only multiply one side of the equation by 100, like, yeah, you fix that side, but it's completely wrong algebraically, and the entire problem will be wrong. Right, so this is just to say this is the same thing as we were doing before. It's just multiplying by 100 is super easy because you just move decimal places around. Like that. So we have 75x equals, so when you multiply 120 by 100, you know that you just add 2 zeros. 75x equals 12,000. Multiply by both sides by 1/75. So you have 12,000 over 75. Now that you would just reduce the fraction by hand, or if you're at home, I can't stop you from using a calculator. So you just can start taking out factors. They both have a factor of 25, so you'd probably take that out. They also both have a factor of 3, so this would actually be the same as 4,000 over 25, right? Which 4,000 divided by 25, well, is 160. So however you get there. If I wanted you to do that with long division, I would put that in the instructions. Okay, so x is 160. And that's all. That's all we really have to say about that. If I give you one involving fractions, find the least common denominator, multiply through by that in order to clear the fractions. If I give you one involving decimals, just figure out how many decimal places you need to move to get rid of decimals to make them all whole numbers, and just make sure you move every decimal place in the equation like that. Okay? Okay, so here's a couple definitions of stuff that'll pop up, not just in this context, but in lots of context in math. And that's when equations maybe don't have solutions, or maybe when equations are kind of trivial and they're true for lots of numbers or all numbers. So first, a definition. A contradiction is an equation that is false for every value of the variable. So you know that from real life. A contradiction is a statement that can't be true. So a contradiction in math is just an equation that can't be true. There's no x that makes it true. So let's do an example, and then when we get to the end, we'll see how we know this is a contradiction. So the only way to know is just to proceed. So just start solving this equation like you would anything else. Get rid of the parentheses using the distributive property. So the left-hand side is going to be 4y minus 7y minus 2. And then the right-hand side is going to be 9y minus 12y plus 15. Right, that's what I said. Yep. Okay. 4y minus 7y minus 2 equals 9y minus 12y plus 15. Combine any like terms you can before you start moving stuff across the equal sign. So 4y minus 7y is negative 3y, and 9y minus 12y is also negative 3y. Like that. Maybe you can look at it now and see that something's fishy, because we're saying that minus 3y minus 2 is the same as minus 3y plus 15. But let's take it one step further, and you'll see. So now you'd start moving stuff around. So you want to get all the y's on one side, so go ahead and add 3y to both sides of the equation. So I added the 3y over here, and then in the same swoop I added 2 to both sides of the equation. So the 2 came over here. But now look what's going on the left-hand side. Minus 3y plus 3y is 0, no matter what y is. And then 15 plus 2 is 17. And now I'm telling you that 0 equals 17, which obviously is not a true statement. 0 does not equal 17. There's no secret here. So what had happened was we started with something that was a contradiction, but we couldn't really see it off the bat. You can't just look at this and be like, oh, there's no numbers that work for that. But when you reduce it and, just try to solve it like you normally would, you get a contradiction. And that is what will always happen with these types of equations. If there's in fact no solution, you'll get it down to a point where you get a statement that's just not true. You get a contradictory statement. And then that's it. So you would say, you wouldn't, well, here's what you would say. You have 3 options. You can just write no solution. That's probably the simplest thing. Or you can use kind of some fancier set notation. So remember in sets, if you just write a set with nothing in it, that means the empty set. So what you're saying to me is the set of all the solutions is just an empty set. There's no solutions in there. And then we also had this kind of more Greek way of writing the empty set, which was the null set, which was the weird 0 with a diagonal slash through it. So that means the empty set. If you don't want to deal with that, just write no solution. Okay? Another definition. An identity is an equation which is true for all values of the variable. So an identity in math goes farther than this. It's like something that's just true because it is. It's like something that just exists. It can't really be proven. It's just inherent. So for our purposes, what this will be is an equation where there's really no number that doesn't work. Every single real number you can plug in for x works. Later on down the road, there might be some restrictions, like only positive numbers work or something. But for right now, you'll see. Let's do an example. So exactly the same as the last one. This just looks like a linear equation that you already know how to solve. And on a test or something, like it won't say, you know, show that this is an identity or whatever, it'll just say, you know, solve this. So just do it. You shouldn't actually really need me to do it this at this point. I would pause the video and just start this problem and see what you get and then pick it back up. Okay? Do that. So but I'll do it anyways for the rest of you. Distribute the 4 and then distribute this negative sign. So you're going to have 4x plus 8 equals 6x minus 2x plus 5 plus 3. Sorry about that lawnmower. So you have 4x plus 8 equals 6x minus 2x plus 5 plus 3. So just clean up the right-hand side. So you should have 4x plus 8. And now I think you can probably see, I don't think you have to go any farther. If you started subtracting stuff from each side, you just get 0 equals 0, which would be fine. But you could actually stop right here, right? Because you have 4x plus 8 equals 4x plus 8, which obviously is true, no matter what x is, right? There's no number you can plug in for x that doesn't make that work. Okay, so it's trivial. It's like, well, duh, obviously that equals that. But what that means is we have an equation here that is an identity. We have an equation that's true no matter what x is. So again, you couldn't tell that just by looking at the original problem. You had to just proceed and just try and solve it as if it were perfectly normal. Okay, so you could write all real numbers. You could also just write all numbers, because we don't really have any kinds of numbers that aren't real. Or yeah, I guess, yeah, that's it. Write that. Just write all real numbers or just all numbers, right? Because x doesn't have a specific solution. It has an infinite solutions. Every number is a solution. Okay, word problem. A sweatshirt is on sale for 30% off. The sale price is $33.60. Find the original price. No tax is involved here. That's just the tag price is $33.60. Okay, so we're going to get more into this very soon, but this is a type of thing where we're translating written English into math. So we need a math way to say, like, what does 30% off really mean? It means x minus 30% of x. And then you have to say, okay, how do you do 30% of x in math? Well, 30% is the same as 0.3, and 30% of x, the word of always means to multiply. So this is good stuff to know. 30% of x is 0.3 times x. So first we declare a variable. X is the original price of the sweatshirt. You could call it S for sweatshirt, call it whatever you want. So just to write it out, you'd say x minus 30% of x equals $33.60. So I already said 30% of x is 0.3x. So it's going to be x minus 0.3x equals 33.60. Right, so math in the language of math, that's what that means. So make sure you're good with that, because that's important. And there's your equation. There's no reason to write 33.60 because the 0 doesn't do anything. You want to write it in the price because we're used to it, but in the equation it doesn't matter. Okay, so now it's just one of those problems like with decimals. X minus 0.3x is 0.7x, right? Because it's 1 minus 0.3. Let's pause real quick, because if you look at where we're at, there's actually kind of a faster way to get to here. 30% off of something is the same exact thing as saying 70% of something. Does that make sense? If I take 30% off of a whole, what I'm left with is 70% of that whole. And what do I got here? That's what I have. 0.7x is 70% of x. So if you're comfortable doing that, that's totally fine. Right? You can jump right to here. If you did that on a test or whatever, I would not fault you, right? So if I say something's 45% off, you could just say it's now 55% of what it used to be, right? Because you know that percents are out of 100. So like 45% off of x would be 0.55x. Okay? I mean, you don't have to do that, but it's just a cute trick that gets you there a little faster. Okay, so we're going to move the decimal place over 1. Really, what we're doing when we do that is multiplying by 10, but for your purposes, you're just going to move all the decimal places over by 1. And by 1, I mean to the right. So 7x equals 336. Multiply both sides by 1/7. X is 336 over 7. Be pretty easy to perform that division, maybe, or use a calculator, or I guess you'd have to actually use long division on 336 divided by 7. Either way, 336 divided by 7 is 48. So don't leave it there, you'll lose points. Sometimes I'll require you to actually write a complete sentence that answers the question, but if I don't, you just have to include units. So say x equals $48, or be more thorough and say the original price of the sweatshirt was $48. Okay, thank you.